So I have this very delicately dummied up here because it is aluminum on aluminum. You don't want to just be dropping this stuff on there because you can damage it. But I'm using this as a guide here, so we're going to have 1, 2, 3, 4, 5. 5 short studs here, 1 short here, 1 short here, and then I'm going to lose my good camera spot, but 1, 2, and 3 tall studs coming through. I'm gonna lose. Nope, that'll work. Another thing while we're in here, this is kind of a little background fun thing that I have. This is what I've used as a straight edge for this project. We took, like I said, we took a gamble on the red Land Rover Discovery and used a couple different methods to find out that the cylinder heads were in fact just fine, and it was just an exhaust failure from the head bolts backing out. Anyways, more to the point, I didn't have a dedicated machine flat edge. However, this item here is actually something I borrowed for, or it was scrap, so I pulled it out of the trash, so it's totally fine. Don't go judging me. This is a print head from a thermal printer for an aircraft cabin thermal printer for printing out instructions from the comms instructions in the cockpit. And it is a very high quality machined piece of aluminum with a coating to protect its surface. So this is what I've used as a straight edge. I actually, now that I bought a nice steel, because the reason this isn't ideal is you want to have the hardest material you can possibly get. In fact, granite and marble are kind of the gold standards for that. But in this capacity, aluminum, machined aluminum will do pretty well. I compared it to my steel straight edge, and it matched up quite well, as best as I could tell with my feeler gauge. This is an aluminum block. You can't just have pistons on raw aluminum blocks, so these actually have a steel liner. What I did is I got this surface all cleaned up, and I take my straight edge, and to the best of my ability, you see there's a lip here which is catching, and I wipe this down really well. And you just want to, this is not scientific, this is just sort of the eyeball, shade tree mechanic version of it, is you want to feel the areas it catches. Well, ensure that ideally it doesn't catch anywhere. A lot of places where it will catch is, so here we go, here's an edge that is not machined, is the threads. A lot of times the threads will have little burrs coming off of them. But what I'm also looking for is to make sure that the steel liner isn't sticking above the surface of it. And the shortfall, of course, with a short one is that you can't, the more accurate reading will come from being able to cover as much surface area as possible. But this is just a quick and dirty kind of, feeling for burrs, feeling for pieces sticking up. And that's how she goes. So now what we're going to do is we're going to put the studs in. The ones to be careful for, this one here, because it has exposure to both oil and coolant. This is a coolant passage, this is an oil passage, so this one gets really gummed up. What we're going to do is just stick our Q-tip in. You don't want to do something that is going to leave material behind. And you don't want these bone dry. A very, very, very thin film of oil is good to let the threads engage. You don't want too much to make it slippery, and you don't want it bone dry where it'll actually sort of catch and ratchet in. So let's go to the bottom, kind of spiral out just since it's a regular thread. You can see there's still all that material in there. So do one more time. And at this point, I've actually done this several times already. It's quite clean. It's just pulling out oil. I'm just looking to make sure it's not pulling out any debris, which it's not. The rest of these are pretty much bone dry, but this is another one here to look out for because it is on the bottom side of the coolant passage. So there you go. Kind of lighter, more of a rusty color. Makes sense with water coming through. This one also here, there's the oil port ends here. We talked about that earlier with the cylinder head, the blocked port that we found. As you can see, I got this surgically clean. There's no evidence of it at all. But same thing, this is above the coolant port. Kind of spiral out a little bit, not too bad. Bottom side, again, exposed to the coolant port. Spiral out, not too bad. One of these, I actually saw a little piece here, hoping it's not a burr. And sure enough, it came right out. Just a little speck of something. I also, first thing I did was I very gently blew in these with compressed air, and a good amount of oil came out, and you don't want to have too much pressure. You'll just make a big mess and get it all over your face. No one likes that. But stick it in, spiral out, and a very thin film of oil will also help prevent any galvanic corrosion, because we have aluminum here and the head bolts are steel. They are coated steel, very high quality coated steel. But you do have dissimilar metals, and something to consider to have a very thin film of oil between them to cut back on that a little bit. So the ARP instructions tell you to do the head gasket and the cylinder head first. What I'm going to do, and I may have even shown it on the video earlier, that it was on before and I took them out. What I'm going to do is put in two short studs on the top side here. Get that started. Obviously, remember, coarse thread into the block. You're going to want to make sure the hex drive is on the outside. If you put it in and that is missing, you've really screwed up because you put the wrong thread pitch in. To make things a little bit easier, I have a 3/16 T-handle driver, and the instructions are adamant. Do not use any kind of torque. They basically, thread them in finger tight. So that's another thing to beware of. I basically get them seated and do, a 32nd of a turn maybe after I feel it going. So there we go. So loose, 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 loose. Just starts to stop there. I go, that's it. That is inch-pounds of torque. Same thing here. Just wind it down. And this is nice to have for this one here, unless you have a shorter one. I'm using a tall handle because it's convenient and it's got a ball end. So dead on would be, here, but I can't turn it. But with a ball end, if you're careful and, you make sure you're really taking feedback from it, if you feel it start to slip, then stop. No bueno. Same thing here. It's about to seat. It's about, okay. So that's seat. So loose, 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 seat. I literally go there. That's all I'm doing. I now have two. So these are going to center everything, but just because it's a big, heavy cylinder head, I like to have one on each end, just a little more, because this is also going to put upper pressure on it. Just to put all of your faith on these studs with a head gasket on it and with the cylinder head on it, I'd rather have a little more security. You could put every single stud in and then guide the whole thing on, but it'll just make navigation a little bit easier if you only have two to deal with as you rock it on. I've cleaned this whole surface, including these two, because you actually do have the head and the head gasket sitting on these two sort of shoulders that come out. So clean this whole surface here. Everything's shiny, basically. It'll come right down to around here. Same thing, and it'll actually come right above there. So that is visible. And here. So, got these two on. Next is the head gasket. In fact, we can just take a little field trip. Alright guys, moment of truth. Breaking up in the brand new name brand L-Ring head gasket. You also, very easy, quick check. Is it straight? Are there bends? Good, because if there are, it is worthless. Throw it away and buy another one. Cannot make that clear enough. Maybe if there's a bend in it and a wrinkle, it'll compress and not be fine. But for all the work it takes to do a freaking head gasket, if it's not perfect, and I have ordered them new and it came in a poor packaging, and I sent it back and it delayed me for some time. Things to note. So this is a nice L-Ring name brand. You'll see, and remember, there are two of these. And if you notice, this is the part number for both. They are the exact same head gasket. There's not a left and a right. You do want to make sure the orientation is correct, but this is the part number for passenger and driver side. Same thing here. They actually, all makes just puts their own name on it. But so you want to inspect, just give it a once over. This is actually an upgrade. The originals do not have this piece here, but this is such a, frankly, poor design. It's good to have this little border. And when it's clamped down and torqued to final torque value, these compress and act as a gasket. You maybe could put RTV on here to do a better job, but I trust L-Ring because they know what they're doing. So we've got oil port, head bolts, and is this going to show up on camera? So L-Ring, and it actually does say top. So you got right there in English, it says top. And then you've got your part number over here. So let's go install it. We've got the two studs in. Go just like this. Make sure it's seated. So you got your studs, or your dowel, your centering dowel pins on the bottom, and your studs on the top. Make sure that this is out of the way and not sitting against the radiator to crush it. And as you can see, this oil port here is closed. This goes into, see, that's what I didn't want to happen. Oh, no problem. This goes into nowhere. This also goes into nowhere. I believe this is an oil return port. I don't love that isn't clearance, and that explains why there's this oil staining here. Maybe I don't even know if you can see it. Let me take you for a ride. I'm just seeing now. I noticed a stain earlier. If I was more of a risk taker, I would Dremel this out, but I don't think I'm going to do that. I want to, but I don't think I'm going to. And now I can't stop thinking about it, but I don't want it. That's gonna introduce oil shavings down here. I'm just gonna have to. I don't like that, but that's how she goes. You'll notice also I didn't clean off. I gave these a light rub on the pistons, but these are gonna get dirty instantly the second it starts running, so it's not a big deal. All the ones that were exposed without turning it on and turning it over, there's cross hatching, there's no pitting. It looks really nice. Very happy with the condition I found the cylinder walls to be in. We have no head studs in, and we have the two centering dowels. Going to be very careful to make sure that it is seated. In fact, I have these two head studs on hand to drop them in right away. But these two are going to be our guide points. Okay, finally, the moment of truth. Exhaust ports out, intake ports in, and then try and set your eye on. Ooh. Just visually set your eye on one of the head bolts. Head bolt ports like that. There it is. Okay, so there's just two little dowel pins holding this in place. So really quickly, I'm keeping pressure on it. Make sure the threads are clear. Make sure they are extremely clear. There we go. First one in. Short head stud, very outside. Come back to that. It is not all the way in. Next head stud. Next side. And start threading. Remember, short. 2 short on the outside. 3 tall in the middle. We'll get them all in. I'm not going to show that, but we got these two here. We'll get all of the studs themselves in, and then I will go over what. So here we go. It just loose, seated, and just a tiny bit. Same thing here. Free spinning. Free spinning. And, okay, so spinning, seated, and that is it. That's all we're doing. Get them all in, then we'll come back in a sec. All right, we have all of our head studs in. 1, 2, 3, 4, and 5 down there. This one's kind of tricky to get at. It wasn't too bad with a couple different tools, but torquing it, we might have to get a little creative. So 1, 2, 3, 4, and 5. Next, well, I guess the predecessor to that is these shoulders here, where the washer is going to seat. You want to get those very, very clean. This one has some staining on it, but it is quite clean. To the extent of, you know, putting brake clean or carb cleaner on a rag and wiping that surface down, because the torque, the pressure of the nut goes against the washer. The washer has to be seated on that and planted on it without spinning. So we'll go back to the instructions here. So screw the studs into the block hand tight. Do not apply torque. Using a clean rag, remove oil from both sides of washer. So what we're going to do is we're going to pull out this whole hardware kit. Well, pull out half of them. We are going to hand clean every single washer that's going on to make sure that they are completely free of oil, grease, or lubricant. Place the washers over the stud and onto the dry, clean spot faces of the cylinder head. Lubricate the stud threads and the bottom of the nuts. So the threads, fine pitch threads on the studs and the bottom of the nut, and only that, with the ARP Ultra Torque Fastener Assembly lubricant. So that's next. Simple little process here. Have a clean rag, sprayed some brake clean on it. Spin, spin, spin. Spin, spin, spin. Dry. Spin, spin, spin. Spin, spin, spin. You get the idea. Okay, next, a little bit of this goes a long way. And since I spilled on my finger, it's going to make it easy. So we just do just a little. That should be enough, really. And then just go on the thread. Give it a quick wipe. Maybe a little more, so maybe that much. And I've already put some on the base of the nut as instructed. So the reason they have you get both sides surgically clean is because one side, the clean side, clamps to the aluminum of the head. Make sure that's seated. Clamps to the aluminum of the head. The other side, as you torque it down, the nut will spin on top of the now lubricated washer. The dry side, and this is in theory, you know, in a perfect execution, the dry side of the washer will stick to the aluminum of the head. I think I said that right. I got distracted halfway through. So that is where your superior clamping force comes from. And if you do torque to yield, they tell you to clean it up really well. You use torque to yield bolts. You'll clean it up really well, but ultimately this is why I believe, and a lot of engineers seem to believe, that this is the superior method. Anytime you're doing performance modifications to a vehicle, they almost always have you doing head studs like this. Next, we'll put the nuts on. Next step, we, one by one, thread the nuts on. And I have, so these are a 5/8 12-point nut. So you see, not just your regular 6, it's 12 points. So you will need a 12-point socket. I'm not going to put any torque on this, but once these are threaded, in fact, gloves are just going to get in the way, so I'm going to leave them off. Just one by one. Remember, there's a skim of grease on these, so they should go on just buttery smooth. If it's anything less than buttery smooth, stop, drop, and roll. Phone a friend. Something is messed up. We have all 10 installed. Just got them engaged. So I'm going to use a short little ratchet. Can't put much torque on it. I'm basically just going to get these seated because this is actually still, it's barely, the weight of it is keeping it on, but it's really not anywhere. So it's going to go through here. I'm going to start with the top row just because there's a little bit less pressure from gravity there. So this is just keeping it in place. Like I said, these should be the easiest threading fasteners you've ever felt in your life. If there's any catches or any resistance or anything, something is wrong. Stop and look into it. Thank you for coming to my TED Talk. Okay, I went through and I did just basically finger tight all 10 of these. So they're all the same tightness. The head is, flush. I put my instructions right on the intake valley This is your torque sequence. 1, 2, 3, 4. You can see the configuration here. It's even kind of asymmetrical. They've got the tabs. They've got all these things all lined up, so you don't mess it up. You've got your, so your exhaust ports are between these. This is what you're looking at. Same thing right here. You get 1, 2, 3, etc. So even in just doing hand tight, which isn't even, we're going for 25 next. I did like maybe 5, maybe 10 foot-pounds. Did that exact same configuration. Okay, this is where those of you who know me and those of you that don't are probably going to give me a great big eye roll. Sorry, I'm just moving all this crap out of the way. So I have 2 torque wrenches here. I have a 3/8 drive. I have a 1/2 inch drive. One is a Capri Tools, which I really like. One is Tecton, which I really like. I am 94.7839% sure that these are the exact same manufacturer in the exact same plant in Taiwan, but they're branded as 2 different ones. There are 3 torque values: 25 foot-pounds, 50 foot-pounds, and 70 foot-pounds. Standard understanding is that your torque wrench is most accurate in its middle half to 3/4 of its range. So our values being 25 to 75. I'm actually going to do the 25 foot-pounds on my 3/8 torque wrench. That's probably just overkill, and I might even be confusing things more, but my reason being, this one is 10 to 150 foot-pounds, which is a huge range. 25 puts it relatively low in its range, whereas this one, that's like a third of the way up. I also have a really nice 12.38 socket, and I'm just going to go ahead and use that. The next 2 values, the 50 and 75, I will use on my 1/2 drive. So what we'll do, take our torque wrench, loosen, this is specific to mine, but general to many, loosen that out, set our 0, here, I don't know if you can see that well, 0, I'm going to spin that until it gets to 25 foot-pounds. Right on, 25 foot-pounds. Hold it in place, tighten the nut, just to verify, 25 foot-pounds. 9 out of 10 of these, I'm going to use an extension on my long 12-point socket. And I prefer doing this direction for tightening, but just because of the engine bay, I'm going to have to go up. Not ideal, but it should be all the same. So get it seated. Put a little pressure on top just to make sure it's very well seated. Remember, we're starting at 1, or we're starting here. This is the first one. Constant pressure down. There's our first click. Confirm, didn't move. Number 2. Better angle here. And remember, I am pressing down at, a 45-degree angle here and pressing up at, I don't want to push down, I don't want to pull up, I want to just go perpendicular to this plane here. So there we go, that's 2. Go up here, this is number 3. Gently. There you go. Check again. That's 3. Sometimes this nut can back off. You want to make sure this nut at the bottom stays, because sometimes as you start clicking, this has not shifted. We've got the 0 at the 25. That means that we are at 25. Tighten that there. Another thing that's very important is I encourage taking breaks between torque values, actually, to sort of let it settle. However, you want to do this procedure in a straight shot. And you don't need to put Loctite, or you don't need to put torque seal on it in between torque values, but you absolutely want to do it at the end. So I just did number 5, double checked it there. Let's go down to 6. Again, not a great angle, but we can make it work. Make sure that's tight, and it is. There, that's click and click. Starting to get one more tricky area. Number 7. Oh, I think that was 1. This is not great, so double check again. Pressure down. Yep, 7 is done. Now we can get a better angle on 8. Make sure that's tight. So this is the angle I prefer because you're working with gravity. Pressure down. Should have gone there. There's click. And there's our click. 8. And I verbalize it to myself when I'm not recording like a goober. Pressure down. That's 9. And 9. Last one here. I am going to switch, take out my extension so I can clear it. This is going to be a tricky one. It's just a terrible angle. And a very short swing. Oh, come on. Okay. Here's what we'll do. We'll get this completely out of the way. Not that much better, but... So we have a very short stroke. It's basically one click. But we should be able to get it done. Come on. There. There. 1, 2. All right, we have completed number 25. What I'm going to do is I'm actually going to take this. I'm going to take my notes on this. We are on the driver's side, 25 foot-pounds. Going to check this off. 25 foot-pounds. Driver's side. Complete. Okay, back for round 2. Generally speaking, you want to use the shortest extension that you can get away with, just because you get the most even delivery of torque with the head as close to the socket, to the fastener as possible. But we're clearing valves here, and there's not much else we can do, but you still always use the shortest extension that you can given the circumstances when you're torquing things down. So this is 50 foot-pounds, half-inch torque wrench set to 50 foot-pounds. Take Juan. So we got number 1 here. Well, let's just center it. Again, not a great angle, but 12.5/8 socket. I'm actually going to come to the front. That way I can at least push slightly better leverage. So our first one here, make sure it's seated. As even of a swing as possible. There's 50, nice big click. That's it. Number 1. Will we clear? Yes, we will. That's 2. Okay. Number 3. Talk to yourself. It helps, I promise. And that's 3. That's 3. Number 4. This is way better. I'm standing at the front. 4. Make sure our nut on the back is tight. It is. We are still at 50 foot-pounds. Number 4 complete. Number 5. Oh yeah. That's click. 5. Number 6. Way over here. And that's click. 6. 7. Way down here. All right. That's 7. 8. Right up front. Gentle pressure down, make sure it's square. Slow, clean, even stroke. There we go. Number 9. All right, that's it. Now, we gonna clear? Can we clear number 10? Ah, see, this is what I was afraid of. All right. How are we going to do this? No, see, it doesn't want to play. We do have the option of using the other one. I don't know if that's going to clear. So we're probably going to have to use the 3/8. Yeah, I don't like that. Hold tight. To say I don't love this is an understatement, but got to work with the tools we have. We are back to the 3/8. We are at 50 foot-pounds. 3/8, 50 foot-pounds, number 10. Seated. Let's see, there's not a lot of swing. There's a bit, but basically get one click out of this whole range. Or less. Come on. Spin. There we go. Track around 2. All right, perfect. So, all 10 driver's side, 50 foot-pounds. 2/3 of the way there. And we can confirm here, 70 foot-pounds, round 3, driver's side, starting at number 1. We have the 1/2 inch drive, 70 foot-pounds. Come over to the spot that we just found, works way better. There we go. Do you want to do one solid motion as often as possible? That's it. Stopped. Number 1, complete. 1, 2. Number 2, complete. Number 3. Good throw. Number 3, complete. Number 4. That's it. Number 4, complete. Number 5. 5, complete. Number 6. Bit of reach. Six, complete. Yep, there we go. Getting to be a reach. Number 7. 7. Yep. Wait, I didn't like that one. Yep. 7, complete. Number 8, right up close and personal. 8. One more. 8, complete. Number 9. Number 9. One more. All right. So 70 is within the range of our 3/8. I don't love it because, again, it's the upper end of the range, but I would rather use one that claims to be able to hit 70, which I'm sure it can, and actually do it versus eyeballing it, taking that risk, especially on one that's right up against the coolant port. I'm gonna do it. Do it right. There we go. There we go. Okay. Really hoping that's going to be all we need. Take sure that's tight. Double check we're at 70. Yeah, that's 70, folks. This is number 10. Keep crunching the radiator with the power steering pump, but shouldn't have to worry about that anymore. Number 10, driver's side. Complete. Thanks for your help.